Hey guys, welcome to our first day of online education. Thank you for those who said present on the first assignment on Schoology. So what you can expect until we go back to normal is about a video or two a week, either me or a video on YouTube or online. That kind of explains the gist of what we're going through. Also, I'll provide you with the notes on Schoology, assignments on Nearpod with the codes, and then just general assignments that you can complete by taking a screenshot of an image and like writing on it, and then screenshotting that and submitting it, or just opening up a Word document where you can access those things on Schoology, answer the stuff on Microsoft Word, and then submit that onto Schoology, or you can even email it to me. That stuff's kind of up to you. I'll find it as long as it's on email or on Schoology. But we're going to wait for roller coasters for when we get back to school. So we're going to move into the next unit, which is astronomy. We're going to go in depth into astronomy, into the Big Bang, into how stars form other things, which will make a little more sense later on. And then after that, we'll learn about Earth's history and stuff like that. But for now, let's just talk astronomy. So, it's going to start weird. We're going to talk about the Big Bang. And in Earth science, we kind of just say, okay, Big Bang, the universe formed. Next, let's move on. In this, we're really going to learn what happened. And in order to understand what happened, you need to forget everything that you know about what is normal. Because things were not normal when the universe first formed. To start, one of the weirdest things about the Big Bang is that everything from this pen to me, you, white plains, the Earth, the sun, the solar system, the entire Milky Way galaxy, and all of the galaxies in the universe were packed into a space smaller than the space between my fingers. Now that doesn't make any sense, right? But in reality, according to physics, that is exactly what happened. And all of the evidence points towards that single point that inflated into the universe. Weird. But that's true. And yet, does it make sense? No. But according to math and according to what we observe in the universe, it does actually make sense to like the biggest minds, things that don't make sense to me. But I take it for what it is, and just thought this was a cool picture. So let's get into the formation of the universe. So just to break this down, the last question on the Nearpod is really just breaking it down these main terms here. So the Big Bang Theory started where everything was at a single point. It then went through the inflation process, not an explosion, but an inflation, like a balloon inflating, right? Where the balloon is there in the beginning and the balloon is there after, right? It's not like it exploded and became something different. It was there and then it's even bigger eventually, just like the universe. Next is going to be the formation of atoms after the universe cools, and then the first stars and galaxies form around the exploded death of a star. All right? So, to break this down, we need to understand that the universe was this spot before time, before space, before matter that we call a singularity. A singularity is a point in space that's infinitesimally small, but it has something in it. Let that sink in for a second. The universe was in a singularity, a point infinitesimally small, but everything was in that one spot. And the only way that's possible is if the universe starts as pure energy. Where did that energy come from? Why did it become the Big Bang? What made that happen? Don't know, but all we know is that it happened. So because it happened, everything exists. We exist. Consciousness exists. Everything that you can see and everything that you can't see exists. So, the universe began as singularity, and then the energy converted into matter, and antimatter. Don't really have to know that for this, but matter and antimatter, they collided, and there was more matter in the end than there was antimatter. And that's what makes up everything in the entire universe. Okay, so step one, the universe was a singularity that then inflated into existence. So the universe inflated into existence, and it doubled in size 90 times. Doubled in size 90 times in a matter of 0.0000000 blah 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 1 second, which is faster than that. So the universe, because the energy converted into matter, it immediately formed into space, because matter has to occupy space. So space was formed, which means time was formed. And that all happened in 10 to the negative 33 seconds. So the universe doubled 90 times in 10 to the negative 33 seconds. And the universe itself expanded faster than the speed of light. All right? How can that be possible? Well, the universe, you could see the inflation began here where it was super, super hot and it began to cool and cool. But how can the universe expand faster than the speed of light? You can check this out in the notes, but I like to give this example. Alright, so imagine there's a pool, right? Here's the pool, right? The pool represents the entire universe at the singularity, and even during the process of inflation. And then we take the fastest swimmer in the entire world and we put them in the pool and we say, hey, swim to the other side. Swim to the other side, so swim in this direction. So that person's the fastest swimmer. This person represents the speed of light. The pool represents the entire universe, and this person can only swim so fast, right? So that's just like the idea that light can only move at a consistent speed, the fastest thing possible in the universe. But that is in the universe. So this person's swimming, da 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 da, moving across at their regular pace. But imagine now inflation begins. The universe inflates. That'd be like knocking down these walls, right? And now the water is going to expand outward, right? So this water here that was once trapped is now expanding outward. What's going to travel faster? The water expanding outward or the swimmer traveling through the water? The water itself is going to expand faster. So if we bring this back to the universe, if the universe is the pool, the water in the pool, or the universe, is going to expand outward really, really fast. And light can only travel at a consistent speed, not as fast as the universe. So the universe was able to double in size faster than light itself could travel, because the universe is the thing expanding. Hopefully that makes sense. These are big ideas. You'll see from the Nearpod that a lot of what I'm talking about, I just think is kind of interesting, and you should just kind of know about because it's really cool. But a lot of the stuff that you're going to be tested on eventually, not yet because none of this is graded, but I am going to make sure you guys are submitting your assignments and that I'm going to give you feedback. But make sure that you know what's in the notes here, all right? So I'm going over it, but I'm giving you more information. So, step 1, the universe was a singularity. Step 2, the universe inflated into existence 90 times, doubling, right? Doubling 90 times in 10 to the negative 33 seconds, or a dot with 32 zeros and then a 1. So really, really small amount of time. So after that, the third step is, because the universe is expanding outward and filling up this newly provided space, right? It began to cool. And after it cooled for 380,000 years after the Big Bang, an atom formed. So the incredible thing about atoms are that they are the reason why light exists. An atom, remember, I don't know if you remember from earth science, all atoms produce infrared energy, which just means they have heat. And the higher their temperature, the more energized their light is, going into visible light, ultraviolet light, X-ray, gamma ray, all these things that are higher and higher energy, shorter and shorter wavelength. Hold on. Sorry, that was my cat. Alright, I gotta finish this up. So, 380,000 years, because atoms started to form, not just any atom, a hydrogen atom began to form, light began to be emitted. If you remember back, this was cosmic background radiation, a bunch of energy emitted all at one time, and that is the furthest light that we can see, and that is the real proof of the Big Bang. So, mostly hydrogen existed, 99% of the universe was hydrogen, a little bit was helium, and a little less was lithium. So everything almost was entirely hydrogen. Alright? So you can watch this YouTube video. But the final step is, after atoms form, once you have atoms, then you start to have gravity. Gravity begins clumping things together and forming really, really hot, dense areas that eventually become stars. The first generation of stars. These first generations of stars included massive, super giant stars. And when you have a supergiant stars go through the process of supernova, also known as exploding stars. And when supermassive stars explode, there's two results. Either a neutron star forms, which is a super dense hot mass that is like crazy dense. Like if you had a neutron star that was the size of a marble, it actually weighed the same exact amount, or close to, the Empire State Building. So it's this big, but it weighs the amount of the Empire State Building. Something even more intense that could form from extremely massive stars are black holes. When supernova occurs in supergiant stars, or when supergiant stars explode, they form black holes. Around these black holes, stars begin to coalesce or clump together, right? They begin to form these massive things called galaxies. Galaxies are going to be where gravity really pulls everything to one point. All right? So, that's all we've got for this. Go on to Nearpod. Your Nearpod code is going to be PFDGS. I want you to answer those questions. You can use the notes to go through. I suggest that because it's going to have a lot of the information that you're going to need. After that, this week, you're going to watch this, I think it's a 5-minute video. You're going to write down one thing that you already knew that the video talked about, 3 things that you found interesting, and then 3 questions that you have about the video that you'd want me to answer, that at least you'd want to be addressed further in the units. Okay? All right. Thank you.